And just like that, we're back to my favorite kind of content, homebrew content. The Rayhen competition is coming up and has a submission deadline of October 7th. I believe it's more than enough time for someone to get started who's never coded before in their life and go to making a game in Lua Player Plus, also known as LPP. And I know early on I said that this is not a tutorial channel, but I would love to get someone started on the road to making a game and submitting it for the competition. So today I'll describe setting up the environment for creating an LPP game. I'll also give you a bit of a rundown on creating a game loop and a very, and I can't stress how small, very small overview on programming to get you drawing a sprite on the screen and moving it around. Now, this is not a comprehensive overview on creating a game, but hopefully it will get you started on the right path. All we're going to do is draw a sprite to the screen and move it around with the D-pad. Nothing more, nothing less. I think LPP is a great starting point instead of the VitaSDK environment, because if you've never programmed a day in your life, explaining build systems, learning memory management, and the actual C language is likely too high of a barrier to jump for someone in 3 months who just wants to make a game. However, if you do want to learn C, there is a book that I can recommend for you. And even then, I would first suggest that you start by making applications for your own operating system before jumping onto the Vita. Now, for those who want to make games in LPP, first thing that we need to do is head over to Rin's GitHub page, over to the LPP repository. In the releases section, click the 4+ link, and in the nightly section, download the eboot safebin file. And then in the LPP Vita R6 section, download the LPP Vita R6 file. You don't need the source code, so ignore that since you're not going to be touching the SDK and you're not going to be making any contributions to LPP. Heading back to the main page of the repository, you can find a link to documentation. LPP uses Lua version 5.2.4, so you'll have access to all the functions of that version of the language, and you can reference the Lua site for that information, but for anything that's LPP specific, such as draw and controller calls, you'll need to reference Rin's documentation here. Rin has it separated by topics, so it's easy to sort through and understand. You will also need a place to write code. Technically, you can use Notepad to write your code, but I'd suggest that you get some sort of editor. Notepad++, VS Code, but my personal preference for Lua is Zero Brand Studio. So first, go ahead and install your editor. Then you need to head over to the folder where you downloaded LPP and extract the R6 RAR file. Then afterwards, take that eboot safebin file that you downloaded and overwrite the file that was extracted inside of the LPP builder folder. We'll use this safebin file as our backup. Now copy the eboot safebin file and paste it into your build folder, and then rename that as eboot.bin. This is the file that will be used to launch your Lua scripts. You will then want to make an empty file named index.lua. This is where you'll write your code. Now your build folder is where you'll be making your game. If you would like to work on multiple projects, I suggest that you make a copy of this folder for ease of use and call it build backup. You can technically make these folders from scratch, but since you're a beginner, I don't really want to add extra stress onto that aspect yet. So before we actually begin to code, we're going to need to cover a couple of programming concepts. The first item is variables. Variables are values and can basically be almost anything. A number, a string, which is just text, an object, or even a table. We have functions, which is a block of code that executes a specific task. We have condition statements. These provide logic to your functions. And we have multiple types of condition statements. But for this video, we'll be using the if statement and the while statement. We'll also cover inputs and drawing to the screen. If you want a more extensive tutorial about all these topics, once you've completed this video, head over to my GitHub page and view the wiki for my Color Avoider game. It's a bit old, but I do my best to provide a full breakdown of every step of the development process, as well as fully commented code. Now that all the preamble is out of the way, you are ready to write your code. So in your code editor, open your index file, located in the build folder. So we're first greeted with this blank screen. And I know that seems intimidating, but let's just think to ourselves, what is something that every game needs? Well, that is a game loop. And game loops need to do two things. It needs to update the logic of the game, and it needs to draw items to the screen. I prefer to keep these two items separated. So we're going to go ahead and create two functions. So our first function is update game, and our second function is draw game. Both of these functions are currently empty, but we know that we're going to want them to run every frame because we're always going to want to update the logic of our game and draw to our screen. When LPP launches, it's going to skip past the code in these functions since they're all encapsulated inside of a function. So we're going to need to call these outside of the function and ensure it runs every frame. Now Lua scripts are read sequentially, so the code that we need to run these functions will need to come after the placement of these functions in this file. So we're going to create a while loop. We'll say while true, ensuring that this loop will always run. And inside of this loop, we're going to add a call for our update function, followed by the draw function call. We do it this way because we want the update to run prior to the drawing of the items to the screen, because if we do reverse it, we're always going to be drawing items to the screen a frame behind, which is not something that we want to do. Next, let's create a variable for the image that we're going to draw to the screen. Let's call this variable image file. Then let's create an X and a Y variable for that image. That way we can store the location of the image with each passing frame. We're going to give both variables the starting position of 0, meaning the top left corner of the screen. As a quick side note, the Vita resolution is 960 by 544. The 00 location is in the top left corner of the screen. The 960 by 0 location is in the top right corner. 0 by 544 is down in the bottom left. And 960 by 544 is in the bottom right. I know the y-axis feels backwards from what you learned in algebra class, but that's just how it works in 2D game development. Now, we're going to want to load the image file at the start of our game, because if we load the image each frame, we're just wasting precious resources, since it's going to be stored in memory. So we're going to create a function under our variables, named startGame. Inside of this function, let's load our image file. Well, actually, first we need to find an image that we would like to load and add into our build folder. I got the perfect one right here. To keep things clean, I'll add an image folder inside of our build folder to store the file. I know this makes no sense since this program only has one singular image file, but if you make a game with over 100 images, trust me, organization is key. Now, let's make a note of the name of the image file and head back into our code. This is where we'll call our first LPP function, load image. So we'll write our image file variable equals graphics.loadImage, and inside of the parentheses, we'll include a string that is the location of our image file. Now for the files within your program, you'll write app0 as the drive, followed by whatever the directory is and the name of the file, because the Vita sees the applications directory as app0. Note, your build folder is the root of your directory, and just like that, the image is loaded. However, we still need to make sure the startGame function is called before our while loop to ensure that the image is loaded before the game actually requires it. So we're just going to add the startGame function right outside of that while loop. We don't add it to the while loop, because if we did, the game would load the image every frame, and not only is it unnecessary, it's a waste of resources. Now, let's draw the image to the screen. So let's head over to the draw function. The first thing that we'll need to do is tell our Vita that we're ready to draw. So we'll need to execute the next LPP function, graphics initiate blend. Then the next thing we're going to need to do is clear the screen to make sure that nothing from the previous frame is still displaying. And this is where we'll use LPP's next function, screen.clear. Now we're free to begin the drawing process. Since we already have loaded our image, let's draw that image to the screen. We'll be using LPP's drawImage function. For the X position of the image, we'll use our X variable, and for the Y position, we'll use our Y variable. And for the actual image, we will be using our image file variable. Next, we'll end the drawing to the back buffer by calling graphics.termBlend. Then to display the graphics to the screen, call screen.flip. And just like that, we have graphics drawn to the screen. However, we still cannot interact with this image, so we're going to need to add some logic in our update function that takes in our button presses and alters the X and Y points of the image. So let's head to the update function and get that going. Looking at the button check function, we can see that we first need to read our controls. So let's create a variable that's local only to this function, named pad. Next, we need to create an if statement for each key press. So this is going to be 4 if statements in total. Inside of each if statement, we're going to write control.check. We're going to then enter in our pad variable, add a comma for our second parameter, and add in the constant for the controller button. In the LPP control section, you'll find the name for each control button. Now that all 4 if statements have been made, we'll need to add an action for each button. For the up button press, we're going to subtract 1 from the Y variable. And for the down button press, we're going to add 1. Remember, like I said earlier, this is backwards from what you learned in algebra. And with the left button press, we're going to subtract 1 from the x-axis, and with the right button press, we're going to add 1 to the x-axis. And just like that, you've created your first interactable application. Congratulations! That means we're ready to build our project. So go ahead and make sure you save your index file, and then head back over to the LPP builder folder and run the build.bat file. In the Insert Homebrew name section, enter in a name for your project and press enter. Then in the Insert Homebrew title ID section, enter in 4 characters to create a unique identifier for your game, and again, press enter. Your project will then generate as a VPK file inside of the current folder. Now go ahead and upload this file to your Vita. Install the VPK file using Vita Shell and run your game. If you did everything right, you should have something similar to this. Now, this is only the first step into making a game using LPP. Next, I advise you to check out my Color Avoider game tutorial on my GitHub page, linked down below in the description. That tutorial will teach you about collision detection, playing sounds, classes, for loops, and drawing text to the screen. After you complete that tutorial, you can look at the code for my games Superhero Chronicles or Galactic Federation for more information about creating games. Though I warn you, those games aren't very well commented or coded, since they were made about 8 or so years ago. Anyways, I hope someone finds this tutorial helpful and begins their journey into making games, whether if it's homebrew, using LPP, or eventually moving over to commercial projects. Just remember the road ahead is long, but don't let that discourage you. Anyways, that's it for today, everyone. Thanks for watching, and thanks for your time.